not the focus. So let me close this. I don't want it. Go back here. Actually, I don't need the rib. So let me just delete the rib. Delete the rib. Where is that? Delete. Don't delete the helix. Helix is not showing here. There we are. There's the helix. And this curve is this circle that I draw is of no use to me, so I'm going to delete it. Okay, good. All right. So now we apply material to this. We have already done it, and because this is a wireframe, it's not a sketch. I don't have to join it. So now we're going to go to generative structure analysis. We're doing static analysis. Okay, and let me see now. So what do we want to do here? We want to mesh this. Okay, so go find the beam mesher. It's right there. We are using linear elements, so select that. This will turn yellow, and the size, roughly the size of each element is 0.349. So let's look at how the mesh looks like. Nothing fancy. And notice that if you put the cursor here, you get the element number and the node number. Now, you know what? Why don't we actually make this size a little bit smaller? Double click on that. Maybe I go to 0.2, half the size. And now when I look at the mesh, it's more curved. You know, actually what I mean is the coils approximate the actual spring much better. Good. Now the rest of the problem is you deactivate that. Okay, and I want to clamp that top point. This top point is clamped, and you apply a force at this bottom point. Now make sure you don't put the force on that point, because if you do, this point is a geometrical entity. It's not a finite element. I'm going to hide this and now apply a force at this point in that direction. Here, this is a dummy value minus 1 pound. Minus 1 pound is a very small downward force. So let's make it 100 pounds. Okay. Now I have to tell the software what is the shape of the cross section. Obviously, it's a circle. So you go to the model manager where the traffic light is. Click on the 1D property. Select the coil, and the cross section is not a rectangular, it's a cylindrical one, and the radius is not 0. Obviously, the radius, I don't know, let's make it 0.25. That looks like. Let's see, 0.25. It's too big, because you can see that the pitch was 0.5. And when I made the radius of this cross section 0.25, they're touching each other. So let me go back to that property. It's right there. Double click on it and make it for the radius. They get 0.125. 0.125. And OK. And OK. So now we have a beam model. We have a beam model. The cross sections are defined here. We apply the load and the deflection. By the way, there is no plane of symmetry here. This coil spring or helical spring does not have any planes of symmetry. So you have to run it the way it is. Just run it. Okay, let's look at the deflection. This is a deflection, and you can animate it. You can see that it's actually deforming. Why don't we make the deflection scale bigger? So make it maybe, I don't know, 1. There you are. You can see this. You can see it. And by the way, if these are distracting us, you can always hide the properties. Don't delete it. Hide it. And now you look at the animation. Okay, which resembles what we had before, except that, by the way, in the other one I put a 1 pound load. Here I'm putting a 100 pound load. But okay, what about numbers? Okay, so the numbers are right there. This is the actual deformed shape. This is with the numbers. So double click on it, and I can go here and change it to material shading. Let me double click on this. And look again, my graphics card is a disaster. It doesn't give me the correct, the correct colors, but the magnitude of deflection is 2.99, assuming that you trust these. By the way, so better, because this is not working, I might as well go to the not material shading. So for example, right there, actually that's not what I mean. Let's go back here, double click. Sorry, that's not what I meant. So material shading is fine. Let's go to this plot, and instead of average ISO, where is this? Right here. I can do it from here. Average ISO, make it symbols. Okay. So if you zoom in sufficiently, you can see that these are actually arrows. You won't have these problems when you change this thing to average ISO. You get a nice continuous color and things like that. I can't do it because the graphics card is not working. So the intention of this problem was to solve this thing with beam elements. And of course, it says that, or you can also do a solid element and compare the results. And then, in the book, I also have the expression for stiffness of the spring when dimensions are given, the pitch is given, the cross-sectional area is given, etc. And you can go ahead and check it against theoretical values, and that takes care of this problem. In the next problem, I'm going to be discussing